Good morning, everyone. And Assalamu alaikum, Raina.
Walaikum salam, ma'am. Good morning,
Okay.
ma'am.
Good morning. Good morning. So yesterday, I think Sir he is also absent today. So I'll be continuing with the a new chapter. I'll be sharing the worksheet for your Neet pre-YQs. So first, let us complete. Let us start with new chapter, and once everything is done, so I'll share the PYQs ka worksheet. Okay.
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 Which chapter, ma'am?
Now we are gonna start with a very small chapter. It is easy. That is amines. And at last we'll do aldehyde and ketone because it's like it has many name reaction, so it will take a lot of time. So let us complete this simple easy chapter which doesn't contain that much reactions. It is very quite easy to understand. Okay.
Okay, ma'am.
Okay then. So our chapter name is amine. One sec, I'll just open this. Okay. The name of the chapter is amine. Uh, Amines. So it is one of the functional group of organic chemistry. Amines are nothing but they are nitrogen containing functional group. Your good morning. Good morning. So here there won't be any oxygen or any sulfur or anything like that. So amines are nothing but they are nitrogen containing functional groups. So just keep one thing in mind, the difference between amines and amides. Okay. Amines and amides. So in amines, the functional group is, sorry, let me write with black pen. Okay. In amines, the functional group which is present, it is NH2. And in amides, there is D wala amides. So in that, you have a carbonyl carbon, carbonyl carbon, carbonyl oxygen, and to that carbonyl carbon if NH2 is attached, so that becomes amines. Okay. So in this we are gonna study about the IUPAC nomenclature, the rules, how we have to name amine system. We will see the preparation of amines, chemical reaction, physical properties, chemical properties, and there are many name reactions in this. So we'll learn how to understand those name reactions and how to keep those name reaction in mind with simple tricks. Okay, so let us start. So first is classification of amines. So we have one topic. First topic is classification of amines. So amines are classified into three categories: primary, secondary, and tertiary. Primary, secondary, and tertiary amine. So we can say it is classified into three categories: 1 degree, 2 degree, and 3 degree. Okay. So in primary amine, the nitrogen will be having two hydrogen. Okay. Now we know the atomic number of nitrogen is 7. Electronic configuration is 2, 5. Okay. So nitrogen has 5 electrons in its valence shell. So it becomes, how can we write it? 1, 2, 3, 4, and 5. Okay. Now, now I can form how many, and the valency of nitrogen is what? It is 3. And what do you mean by valency? Valency is that how many bond can an atom form? So nitrogen can form total 3 bonds. So these are the 3 bonds. So it can be with any atom. So let me write H only, hydrogen. So these 3 electrons which is involved with forming bonds with hydrogen. So this 3 electron will be my bond pair, and this 2 electrons which is present over the nitrogen, it is known as lone pair of electron. Okay. So in primary, it is NH2. So nitrogen will be having 2 hydrogen. In secondary, nitrogen will be having only 1 hydrogen. And in tertiary, nitrogen will won't be having any hydrogen attached to it. That's it. So primary 2 hydrogen, secondary 1 hydrogen, and tertiary 0 hydrogen. Okay. So these are the only 3 classifications of amine, not more than that. Uh, what if I tell you just you have to classify the following amines as primary, secondary, or tertiary. Okay, so the first question is C2H5 2NH CH3 thrice N C2H5 NH CH3 C6H5 NH2 CH3 CH CH3 NH2 NH C6H5. So no matter how complicated the structure is, you just have to look at what nitrogen. Okay. No need of looking at any compound. Just look at nitrogen and just tell me how many hydrogens are attached to nitrogen. So in the first structure, only 1 hydrogen is attached, and we know 1 hydrogen means it belongs to secondary amine. So this is secondary. The second structure, it is only nitrogen. So this becomes tertiary. This is nitrogen and H. So this is also secondary. This is NH2, which means it is primary. This is primary, and this is secondary. That's it. You just have to classify whether the following amines are primary, secondary, or tertiary. Okay. Now let us move. Let us move further. Nomenclature. Nomenclature is quite easy. So basically, amine, we know functional group is NH2, no doubt. And amine is a functional group, so most probably the you have to substitute the E, parent carbon ka E with amine. For example, it is ethane. So ethane ka the alphabet E, you have to substitute it with amine. So that becomes ethanamine, butanamine, propanamine. Okay, like that. So for example, if I give you an example like this, so where is the example? Okay. So example is CH3NH2. So you can see there is only one carbon. So one carbon, which means the root word is meth, and you can see only single bond. So that becomes methane. You just don't have to write the E of ane, and you have to substitute it with amine. That becomes methanamine. Okay. Next is CH3, CH2, CH2, NH2. So this is meth, eth, prop. Prop, prop. Everything is single bond, so that becomes propanamine. Propanamine. Wait a sec. I wrote wrong spelling. So that becomes propanamine. Next question. CH3, CH, CH3, NH2. So again, this is also propane. This is also made. It also consists three carbon, but it is not You can't write directly propanamine because when you compare it with the above structure, the amine is present at first carbon, but in the second structure, the amine is present at second carbon. So you have to specify the amine's position as well. So that becomes 1, 2, 3. So at second position, you have an amine group. So that is 2 propanamine. Or you can write propane 2 amine. No issues. Done? Okay. Okay. If I have, so this was an example of primary amines IUPAC nomenclature. What if my compound has secondary amine? तुम लोग को feasible है ना इंग्लिश ना सब feasible है ना इंग्लिश से प्रॉब्लम नहीं है ना बोलना कि मेरी इंग्लिश बहुत अच्छी ओके चलो नेक्स्ट इज CH3 NH CH3. So again, this is an example of secondary amine, but we have to name it. Again, the IUPAC nomenclature will be. Now, whenever, just keep one thing in mind, whenever it is secondary or tertiary amine, you have to start with capital N. Capital N, it starts for amine ka N, okay? Nitrogen ka N. Okay, so let us start with capital N. Now, now this is a symmetric structure. If I break this structure into half, so you can see here it is also methyl and here it is also methyl, right? So in secondary and tertiary, your name will be like this: alkyl amine. One will be a substituent and one will be a parent chain. Okay. Now both are symmetric in nature, both are methyl. So you consider one as parent chain and the other one as substituent. So I'll consider this CH3 as substituent and I'll consider this CH3 as my parent chain. Or you can either vice versa. Both are CH3, so no need of getting confused between okay. So N. So first you have to write the substituent's name and then parent name. So substituent is meth. So that becomes methyl. This is methane amine. Methanamine. Methanamine or methanamine. Okay. So this is N-methyl methanamine. So one is substituent and the other one will be parent chain. Okay. What if my compound secondary amine is unsymmetric in nature? So that time what you'll choose, like for example CH3, CH2, NH, CH3. At this part, what you will choose? Now, you have to always remember, so you have to write N. बंद करो. Okay. AC को इधर रखना था. Record है. Okay. Okay. Fine. Now in this structure, my compound is unsymmetric in nature. So to the right side of my nitrogen, there is a methyl group, and to the left side of nitrogen, there is two carbons. So you have to always remember the minor carbon will be my substituent. So the minor carbon is meth. So that would be my substituent. So that is N-methyl. This is 1, 2, ethanamine. So this becomes N-methyl ethanamine. Okay. Next question is, okay. Okay. Next, let us move further about the tertiary amine. CH3, N, CH3, CH3. This is tertiary amine. Again, the structure is symmetric. You consider either, okay? So again, you just have to consider one parent chain, and the other two will be my substituent, okay? So I'm considered this as my parent chain and the other two as my substituent. Now there are two substituent, so you have to write N comma N dimethyl methenamine. So that becomes N comma N dimethyl methenamine. Next, C2H5 N CH3 CH3. Okay. Again, the substituent will be the minor carbon. So minor carbon is CH3 and CH3. There are two substituent. So that becomes N comma N dimethyl meth eth ethenamine. I can't breathe. It's very suffocating. So that becomes N comma N dimethyl ethenamine. तुम न्यू हो? फर्स्ट लेक्चर? अच्छा वो absent. So that is N comma N dimethyl ethenamine. Next, CH3 N C3H7 C2H5. Okay. Again, first, this is also an unsymmetric tertiary amine. So first, you have to do what? You have to choose which are the minor carbons. So this C2 and CH3, they both are minor, and this will be my major carbon. So this major will be included in my parent chain. Okay. So now there is ethyl and methyl. So alphabetically E comes first. So you can write N ethyl, N methyl. Three carbon means it is propanamine. That's it. Okay, fine. Okay. So what are the common names? So these it is quite easy. No need for further examples. So I'll just give you some common names which you have to keep in mind. So one is aniline. When NH2 is attached to a benzene ring, so that is nothing but aniline. So this you'll come across in many name reaction as well. So aniline is NH2 attached to benzene ring. So what would be its IUPAC name? This is a common name. Aniline का IUPAC क्या होगा? नहीं, no need. What is the parent carbon? It is a benzene ring. So we have very good benzenamine. You have to just substitute the benzene ka the last E alphabet by amine. So that becomes benzenamine. This is not a tertiary one. Yes, it is also benzenamine. For example, okay, if I put a tertiary, that's a good question. So if it is like this, NCH3, and here it is C2H5. That time also this my benzene ring will be my will be my parent chain. Okay, again, so this becomes N ethyl, N methyl benzenamine. Benzenamine. Common name is different. Common name is aniline. So they won't even in PYQs, or even in NEET exam, they won't tell benzenamine. They'll say aniline. But what if this year they might change aniline with benzenamine? So you just don't have to get confused. Okay, fine. So these were some common examples which we did. We got to know how to name an amine functional group, what is primary, secondary, and tertiary. We also classified the following amines into primary, secondary, and tertiary. Okay. Nitrogen ka valency is 3, It has one lone pair of electron. Why? Because it has 5 electron in its valence shell. That's it. And okay. So what would be the nature of amine? Whether it will be acid or it will be base. Why acid? कोई बता सकता है whether it will be acid or base? You did this part in your 12th standard in your boards. There was one chapter known as ionic equilibrium. स्टेट के थे ना? हम्म। क्या था? किसी कोई एक साइंटिस्ट ने बोला था, किसी साइंटिस्ट ने कुछ तो बोला था लोन पेयर ऑफ इलेक्ट्रॉन के बारे में. लुईस बेस. बंदे ने क्या बोला था? जो भी बेस होता है वो अपने लोन पेयर ऑफ इलेक्ट्रॉन को एक्सेप्ट करते कि डोनेट करते? डोनेट करते. Acid doesn't have any lone pair of electrons, so obviously it will accept the lone pair of electrons. So base is having a lone pair of electrons, so it will donate it. But there are also some criteria which we will learn. So how it will, whether it will be a strong base or weak base or moderate base, like that. Okay, very good. So amine, it is nothing but a base. They are basic in nature because they have lone pair of electron in it. Okay, now let us see. The next part is preparation of amine. Okay. So preparation of amine, the first preparation is by nitro compounds. First from now we are going to prepare amines. Okay, we are not reacting amines with any stuff. Okay, so nitro compound means we are gonna take any nitro group. What will be what we are gonna add the reagent? We'll look into it. So if we are taking nitro group, so for that you have to do reduction. Why? I'll tell you. Reduction. So we know nitro ka structure is NO2. R N O2. Okay. Now, if I want to convert nitro into amine, that is NO2 into amine, we have to remove this oxygen, right? And removal of oxygen is nothing but reduction. So for reduction, what will be the reagent? बता सकते हो? What we are going to add? We are going to add what? Hydrogen. So yes, so the reagent will be H2. But hydrogen gases are hydrogen is not a solid. Hydrogen is not solid in nature. It is in gaseous state. So hydrogen gases are quite explosive in nature. To suppress that explosiveness, we have to add catalyst as well. No dry ether. Dry ether is for metal, sodium and magnesium. But for hydrogen, you have to add what? Catalyst. So that catalyst is nickel, palladium, or platinum. Okay, nickel or platinum or palladium. What if I don't have these reagents in my lab? तो reaction को फेंक देंगे नहीं. What we'll do? We'll look for a substitute. If Abrar sir is not there, so okay. They substituted Abrar sir with me. Okay. So like that only. अगर reagents है ही नहीं तो ऐसे नहीं कि खत्म इसके बाद कोई reaction होगा ही नहीं ऐसे नहीं. कुछ तो ढूंढेंगे ना substitute ढूंढेंगे. तो उसके लिए आप जो next substitute reagent is tin in HCl. So they both are used for reduction of nitro compounds. That's it. Just remove this oxygen and add hydrogen. So you'll get, अरे यार, okay, you'll get NH2. Always remember whenever you are reducing a nitro compound, you'll always term. Okay, so the first reagent, nitro compound reduction, always keep in mind whenever you are using hydrogen gas, you have to use a catalyst, otherwise it is quite explosive. खत्म, लैब को खत्म करना है तो कैटलिस्ट मत यूज करो, बट अगर नहीं खत्म करना तो कैटलिस्ट यूज करना पड़ेगा. ओके, अगर ये कैटलिस्ट नहीं मिला तो यू हैव टू यूज टिन इन HCl. दैट्स इट. ओके, so this is or. So I am getting a primary amine. For example, if I am taking nitroethane, CH3, CH2, NO2, the reagents are same. Tin in HCl, H2 plus Ni or platinum or palladium or SnHCl. What if I don't have tin because it is quite costly? So वापस cheap पे जाएंगे. Fe plus HCl is also fine. Okay. Again, you have to reduce this O2 into H2. So this becomes CH3, CH2, NH2. So here the nature of nitrogen. Nitrogen is containing two hydrogens. So this is a primary amine. And the name of the structure is ethanamine. Done? Any question regarding this? No. Whenever you're using sodium metal, that time you have to use dry ether. Because sodium metal is also quite explosive. It catches fire once it gets in contact with water. So that's why we're using dry ether. What do you mean by dry ether? A ether which is not having any moisture content. 0% moisture. यानी पानी का कोई भी content नहीं होगा उसमें. Next, what if, okay. Now tell me the product of this particular reaction. NO2 को मुझे convert करना है, हाँ, aniline में. Reagents. Suggest the reagent. द अबव रिएजेंट. बट ऐसे नहीं लिखोगे, लिखना ही पड़ेगा H2Ni. मैं Ni यूज करती हूँ. चलो, Ni, निकल, प्लैटिनम और पैलेडियम. Basically these metal catalysts, they are reusable. You can reuse it. जब तुम रिएक्शन करोगे, कैटलिस्ट का मतलब क्या है? What do you mean by catalyst? It will just initiate the reaction. It will speed up the reaction without participating in it. There are two types of catalyst. One is positive and the other one is negative. Positive is used to speed up the reaction. Negative is used to slow down the reaction. For example, if I'm going for a vacation, so what I'll do, I have started one reaction. ऐसे नहीं कि मैं इसे stop कर दूंगी, नहीं. So I'll add a negative catalyst to it. So by adding the negative catalyst, that reaction will get slow down. So it can take 1 month, 2 months to complete it. But what if I don't have any time? I have to submit my thesis or something like that. So that time you're gonna add a positive catalyst. But ऐसे नहीं कि catalyst डालने के बाद वो उसके साथ relate होना चाहिए. Done? Uh, just tell Aditya, text Aditya, he's calling me. That he's in Neet. We are in Neet room. Okay. Rahina, you're getting it right?
Yes, ma'am.
Okay. If you have any doubt, you can ask me.
Okay, ma'am.
Okay. Chalo then. Next is from alkyl halide, which is known as Hoffman ammonolysis method. So the first name reaction is Hoffman ammonolysis method. कहीं तो सुना है Hoffman, कहाँ पे? सुना. Hoffman bromamide degradation. और एक था. One more was there in halogen derivative. कोई ऑप्शन नहीं. Hoffman substitution, Hoffman elimination, Hoffman पता नहीं, Hoffman bromamide. बट हेलोजन डेरिवेटिव में भी एक हॉफमैन था, एलिमिनेशन था. एक था सेटजेफ एंड द अदर वन वाज हॉफमैन एलिमिनेशन. सेटजेफ में वी वर गेटिंग मोर सब्स्टिट्यूटेड अल्केन एंड इसमें लेस सब्स्टिट्यूटेड अल्केन एज मेजर प्रोडक्ट. दिस इन माइंड. एंड व्हाट इज द रिएजेंट यूज्ड इन हॉफमैन एंड सेटजेफ? नहीं, चलो थोड़ा थोड़ा थोड़ा, अब भी तो किए थे। Alcoholic KOH, very good. If we use aqueous na, तो it goes under nucleophilic substitution. And if you're using alcoholic, so it undergoes elimination. यानी alkene मिलेगा हमें. याद रखो, याद रखो. ऐसे कैसे भूल सकते हो? नहीं भूलना है. कैसा होगा फिर? हाँ जी. ZnHG वो भी रिडक्शन है. आई थिंक इन क्लेमेंसन रिडक्शन. क्लेमेंसन, वुल्फ किशनर, वो सारे रिडक्शन में आते हैं वो. हाँ, वो दोनों में से. ठीक है, चलो लेट्स मूव फर्दर. पढ़ के भूलते नहीं रे, उसको रिवाइज करना रहता है. नेक्स्ट इज फ्रॉम अल्काइल हैलाइड which is known as Hoffman ammonolysis method. Ammonolysis, what do you mean by ammonolysis? Ammonolysis, lysis यानी breakdown. जैसे glycolysis, glycolysis में we are breaking down glucose and we are getting ATP XYZ. In ammonolysis, same as you're gonna what you're gonna break down, you're gonna break the ammonia NH3 को break करोगे. ठीक है. So the reagent for this, हाँ जी. So from alkyl halide, यानी the reagent, the starting reagent will be alkyl halide. So you can take RX, then इसमें you're gonna add NH3. So when alkyl halide is treated with ethanolic solution of ammonia, it gives a mixture of primary, secondary, tertiary, as well as quaternary amine. Fine. Okay. So what will happen? This lone pair of nitrogen will attack on X or R. It will attack on R. Very good. Why it won't attack on X? Because X is negative and nitrogen is also having an electron in it. So both are like species. तो like repulsion होता है, वो attract नहीं करता है. तो the lone pair of electron will attack on R and X. X is halogen and halogens are good living groups. So this will leave. So what you will get? ये X और ये H HCl के तौर पे निकल जाएंगे, तो हमें मिल जाएगा RNH2. डन. ओके, वेरी इजी. ये बन गया हमारा प्राइमरी अमाइन. अगेन व्हाट आई विल डू, इसमें वापस से मैं RX ऐड करूंगी बिकॉज इन हॉफमैन अमोनोलाइसिस मेथड we are gonna get a mixture of primary, secondary, tertiary as well as a quaternary amine. Quaternary amine means what? नाइट्रोजन को, yes, quaternary ammonium salt. Yes, very good. So again the nitrogen ka lone pair will attack on R and this X will get removed with H. तो ये बनेगा RNHR. The byproduct will be HCl. H2 का एक H और X, तो it will remove in the form of HX. Okay. Again nitrogen is having lone pair. So this is my secondary amine. Again in this I am adding RX. So the lone pair of nitrogen will attack on R. This X will get removed in the form of HX and I'll get R, N, R and R. अभी भी नाइट्रोजन के पास lone pair है. Now also it is having lone pair of electron. So again it will attack on RX. Then we will get a quaternary ammonium salt. Now my reaction will stop over here. Why? Because lone pair of electron is not there now. Okay. In quaternary ammonium salt, that's it. अभी उसने बताया, बस हो गया. मेरे से इसके बाद कोई रिएक्शन नहीं होने वाला है because nitrogen is containing positive charge. And what do you mean by positive charge? It is electron इलेक्ट्रॉन रिच और इलेक्ट्रॉन डिफिशिएंट. अब इसके पास इलेक्ट्रॉन है नहीं है तो किसी पे अटैक करेगा भी नहीं. यस, वेरी गुड. So this is alkyl halide Hoffman ammonolysis method. The starting reagent is alkyl halide, ammonia, ethanolic, alcoholic solution में ये सब होने वाला है. Okay. In this you're gonna get a mixture of primary, secondary, tertiary and quaternary ammonia, amines, ammonium salt. This is quaternary. Quaternary, or we can write 4 degree or quaternary. That's it. Okay. So this process of cleavage of CX bond by NH3 molecule, it is known as ammonolysis. Primary amines can be prepared by this reaction by taking large excess of ammonolysis. Okay, fine. So, but the order of reactivity. Now the X can be here. The X can be fluorine, chlorine, bromine, iodine. Chalo. Now tell me the reactivity order. Which will be more reactive in nature? Iodine, very good. Because we need a good living group and fluorine is not a good living group because it is electronegative in nature. तो वो easily निकलता नहीं है, उसको निकालना पड़ता है. तो बनेगा R क्या है अभी, BR, RCl and RF. Done. That's it. The reactivity order is somewhat like this. This reaction is a nucleophilic substitution reaction. Why? Nucleophilic substitution, no? You are substituting a nucleophile. NH3, nitrogen पे lone pair of electron है. So this is a nucleophilic substitution reaction. In this reaction, ठीक है, कोई बात नहीं, इतना ही काफी है. This is a nucleophilic substitution reaction. That's it. इतना ही है और कुछ नहीं. Basically, aryl halides, they don't give these reaction. Tertiary butyl bromine, okay, fine, काफी है. Next, हम जाते हैं from nitriles. What do you mean by nitriles? Nitriles. CN. Okay, correct है. From is NC. NC, no? Yes. Nitriles. Again, nitriles we have to just reduce it. So by reduction method. Okay. So we are going to take RC triple bond N. Okay. Now again we have to do reduction. So H2 in Ni or sodium amalgam in ethanol. So what will happen? Now we are only concerned about this carbon and this nitrogen. So what you have to do, you have to convert R C single bond N. That's it. Attach the hydrogen. हाँ हाँ क्या, अरे रुको रुको, पेशेंस, अभी हाइड्रोजन भी ऐड करना है, मैं बोल रही हूँ. Triple bond is getting converted into single bond and now complete the valency. This will become H2 and this will become H2. So this is RCH2 NH2. अभी करेक्ट है. हाँ, मिटता रह गई ना. Okay. For example, if I'm taking CH3, CH2, C triple bond N, H2, Ni. Again, we have to reduce this part. We have to add hydrogen to this part only. So this becomes CH3, CH2, CH2, NH2. So this is propanamine. Mm. That's it. ओके, आई हैव वन क्वेश्चन. अब मेरे पास नाइट्राइल है ही नहीं. आई डोंट हैव एनी नाइट्राइल. सो फ्रॉम वेयर आई प्रिपेयर इट? KCN. एंड आई रिएक्ट इट विद व्हाट? KCN को मैं किसके साथ रिएक्ट करने के बाद आई गेट नाइट्राइल? Alkyl halide. Very good. Alkyl halide. Okay. So this reaction is used for series, that is preparation of amine with more carbon atoms. Okay. What if, for example, if I don't have nitrile, so I have to prepare nitrile in my lab. So how I will prepare it? So for example, if I'm taking CH3Cl, I'll treat it with alcoholic KCN, potassium cyanide. Again, the negative part of the CN will attack on carbon और ये Cl निकल जाएगा in the form of KCl. Okay, this will form CH3CN. Now we have to reduce it in the presence of H2, and the catalyst is nickel. Now we are only concerned about this CN, so this will be CH3 CH2 NH2. हाँ, कर सकते हैं ना इसमें शायद से. हाँ, अल्कोहलिक यूज करना है, एक्वियस नहीं. अल्कोहलिक KOH का अल्किन बनता है. यस हम. ओके, नाउ there is one name reaction I have to just, I forgot. You have to keep one thing in mind. If you're using H2 and Ni, so it is just a reduction. But if you're using sodium in amalgam with C2H5, then that reaction is known as Mendius reduction, right? So I can write this statement: the reduction of nitriles by sodium in amalgam Hg and ethanol is known as Mendius reduction. So this is my second name reaction. First one was Hoffman ammonolysis reaction. Second reaction is Mendius reduction. Mendius. How can you keep the reagent in mind? M, alphabet M. What comes after M? N. Then for sodium. Sodium in amalgam and C2H5OH. Done. N for it is not sodium. I'm just telling the symbol of sodium. Fine. So this is Mendius reduction. Okay. Next reduction is from amides. Amides, C double one O NH2. Fourth one, from amides, again we are reducing it. You have to write it. Okay, you can write. Every time we can't use H2 H2 H2. सबके लिए थोड़ी ना है. What if it is amides? तो कोई reducing agent बता सकते हो? लिथियम एल्यूमिनियम हाइड्राइड. ओके, वेरी गुड. और कुछ? ठीक है, काफी है. ऑक्सीडाइजिंग एजेंट PCC, K2Cr2, पोटेशियम डाइक्रोमेट, पोटेशियम परमैंगनेट, KMnO4, Cr, हाँ, CrO3, क्रोमेट कुछ तो ना. PCC is also there. Yes, आ रहा है. बट कहाँ यूज करना है वो नहीं आ रहा है. अप्लाई करने नहीं आ रहा है. हाँ, यही तो दिक्कत है. देखो, ये एक बुक है जो अपने ही इसमें है, अपने ही एकेडमी में. इसमें बहुत अच्छा है MCQs. And पूरे ADCI में only Victor uses this book. We have a lot of book in this library में. Library यानी वो cupboard में. आप भी ले सकते हो, मुझे नहीं पता, मतलब बहुत सारे बुक्स हैं अपने ADCI में. न्यू ADCI रिसेप्शन में कबर्ड है. करता है बहुत. He studies. He has a very high grasping power. Within short, with like he joined Jan में. He has completed Jan ending में. Only 2 months. Fine. सबका अलग होता है. हाँ जी, जा सकते हैं. बट अगर आपका होने के बाद आपको उसी दिन सबमिट भी करना है. ऐसे नहीं कि आप घर लेके जा सकते हो, बट बस पूछ के लेना. ओके, लेट अस मूव फर्दर. By amide reduction, every time it is not feasible to use H2 and that stuff, so for that you have to use a reducing agent, that is lithium aluminium hydride. यहाँ पे lithium aluminium hydride है. H पे there is negative charge. Whenever hydrogen is having positive charge, then that is known as hydrogen ions. But if it is having a negative charge, so it is acting as hydride. Okay, so I can write like this. It is RC double bond O NH2 in the presence of lithium aluminium hydride H2O. हम वाटर ऐड क्यों करते पता है कुछ? वो भी है, मेटल को भी वापस से रिकवर करने के लिए. यस. ओके, नाउ again what we have to do? NH2, we don't have to write, you don't have to change this NH2 because NH2 is amine. What you have to reduce? The C double bond O. That we are only concerned about this carbonyl carbon. So what will be we are reducing it, right? So we are going to get RCH2 NH2. That's it. So you have to remove this two bonds. So for two bonds, you have to add two hydrogens. So this carbonyl carbon got converted into normal CH2 group. So we have reduced it in the presence of lithium aluminium hydride. Okay. If I'm okay, identify the product CH3CONH2 in the presence of, I don't know, I'll get amine. But kaun sa amine? That too I don't know. So predict the reagent and predict the product. You're gonna get what? Ethanamine. Okay. Agent? Are be louder. H2O. Will it come first or second? It will come. It is a second reagent. Okay. H2O. The first reagent is lithium aluminium hydride. Lithium aluminium hydride. And the product is ethanamine. CH3, CH2, NH2. So this is ethanamine. That's it. No matter how complicated the structure is, you just have to identify that which portion I have to reduce. That's it. No matter how for example, if it is containing hundreds of carbon also, you just have to keep that in mind. Wherever you'll find a carbonyl carbon, you just have to reduce it. No need of IUPAC name. Okay, fine. Next name reaction which we okay, CH3. Next is name reaction. The third name reaction which we are gonna study is Hoffman bromamide degradation reaction. Okay. By the name itself, bromamide. Bromamide. We are gonna add bromine and we are going to add amine. That's it. Okay. By the name itself, bromine and amide, we are going to add degradation, which means we are going to degrade it. We are going to we are going to break the amide group into two halves. Okay. So that is degradation. So you don't have to learn, you just have to break the following name reaction. कर दूं on? मुझे दम दिख रहा है, इतनी ठंडी लग रही है इसमें। ये नहीं है, रिमोट लेके आया हूँ, है नहीं रिमोट, नहीं होगा ना नीचे। ओके ओके, so the reagents are Hoffman bromamide, bromine, and amide. So again, this becomes RC double bond O NH2. We are gonna add bromine plus KOH. We need a reagent as well. We need a solvent as well, potassium hydroxide. So what will happen is that you have to degrade it. Degrade it. You have to break this CO and you have to attach this NH2 to the R group. So that becomes RNH2. Okay. You have to remove this CO. If you are taking, for example, if you are taking CH3, C double bond O NH2 plus Br plus KOH, and the resultant product will contain one carbon will be less in the resultant product. That is, this carbon will get removed. This is metheth. This is ethanamide. So ethanamide, from ethanamide, if you are doing Hoffman bromamide degradation, you will get methanamine. One carbon less, methanamine. Okay. In the above reaction, same. It was same. But if you are taking ethanamide, you are getting ethanamine only. You're not reducing. You're not removing any carbon out of it. Okay. But if you have to degrade it, if you have to remove one carbon, so that time you have to use this following reagent and you have to perform Hoffman bromamide degradation reaction. Done. If you're using benzamide, so what would be the product? Benzamide. Benzamide is nothing but benzene. क्या है ये? You're using benzene को जोड़ दो amide, that is C double bond O NH2. Again, we are using Hoffman bromamide Br2 plus KOH. So you will get what? You will get aniline. Aniline. This is benzamide. Okay, that's it. Fine. Is it easy? You have to copy it, right? Jessica, you? पता नहीं, देखते. You can copy it. Sure. Let's move further. The last preparation of amine is Gabriel thalamide synthesis. So this is my third or fourth name reaction. First was Hoffman ammonolysis, second was Mendius, third was Hoffman bromamide, and the fourth one is Gabriel thalamide synthesis. This is also quite simple, very simple. So let us see Gabriel thalamide synthesis. This is my sixth reaction. Gabriel thalamide. Gabriel thalamide. Again, the functional group present over here is amide. Thalamide ka P is silent. That is thalamide. Okay. So basically, here we'll be using three reagents. Three reagents. First is you're gonna use, okay. First you're gonna use alcoholic KOH. Second reagent is RX, and the third reagent is aqueous NaOH. Okay. First, second, third. Three reagents you're gonna use. So how we are using? Let us see. Okay. So let's write the thalamide ka structure. Thalamide, it is a benzene ring. It has functional group as amide. This is NH. So this is my thalamide. Okay. Now, what is the use of adding alcoholic KOH? Why? Because basically this thalamide, na, it is not reactive in nature. It becomes reactive when it will have a negative and positive charge. So that's why we are treating it with alcoholic KOH. So this is my thalamide. So I'm doing, I'm treating it with alcoholic KOH. So we know nitrogen and hydrogen mein, hydrogen is positive, nitrogen is partially negative. In this also, potassium is partially positive, OH is partially negative. So what you have to do? You have to substitute this hydrogen, partial positive, with partial positive potassium. So that becomes, we will get a salt. Double bond N, K, double bond N. So this is negative and this is positive. Okay. Now this product, this salt's name is potassium thalamide. And this is thalamide. Okay. Now I can go for my further reaction. Why? So basically, thalamide was not reactive, so we made it reactive by treating it with alcoholic KOH. So this is alcoholic. Next reagent is RX, alkyl halide. Again, what we are going to do? Now this become reactive in nature. So we are gonna substitute in RX. So we have partial positive charge as R and negative charge is X. Okay. Again, we are gonna substitute the partial positive K with my R group. So that becomes N R K. Okay. And the name of this is N alkyl thalamide. We are not done with this. Next, last reagent is aqueous NaOH. So what will happen is that this N and R, it will remove in the form of RNH2. We have to break this bond and this bond. What will be the resultant byproduct? ONA, ONA. So one thing you might have noticed is that the reaction which we did, like all the five reactions of six reaction of the preparation of amine, everything was second primary amines. In Gabriel Thalamide also, you are going to get primary amine only. Okay, no secondary, no tertiary. You're getting only primary amines. The secondary and tertiary amine mixture was found in which name reaction? Hoffman ammonolysis reaction. In Hoffman ammonolysis, you were getting a mixture of primary, then after primary, you were getting secondary, secondary ke baad tertiary, tertiary ke baad quaternary. Why? Because there was lone pair of electron which was on nitrogen. Once the lone pair of electron was once the reaction stopped at quaternary ammonium salt. Okay, but in all the five reaction, you are seeing that there was only primary amine. Okay, this were the name reaction. Again, we'll revise it one time. So the preparation of amines, the first was nitro compound. It was reduction. Again, the reduction reducing the agents were hydrogen in nickel or palladium platinum or tin in HCl or ferrous in HCl. You were getting primary amine. From alkyl halide, that was Hoffman ammonolysis method, you were getting a mixture of primary, secondary, and tertiary quaternary amines. And the reactivity order was Ri, RBr, RCl, Rf. From nitrile, again, it was a reduction, but for this, the reagents were same hydrogen in nickel, but there was one more name reagent that was sodium amalgam and ethanol, and that name reagent was Mendius reduction. Again, you are getting amine, primary amine. The next was for from amide by reduction again. Now, in this amide, you are going to reduce it by reducing agent, that is lithium aluminium hydride. With lithium aluminium hydride, you have to add water as well. So you will get amine, primary amine. But what if I have to remove, what if I don't want, if I want to remove one carbon from my amide, that time you're going to go for degradation reaction. And that is Hoffman bromamide degradation, where the reagents, where the starting material is bromamide, amide, bromine, KOH. And you will get respective you are going to get primary amine only, but the carbonyl carbon will get removed, it will degrade. Okay, and the last name reaction, it is quite simple: Gabriel Thalamide synthesis. Gabriel Thalamide synthesis, again you can see Gabriel Thalamide synthesis, it is made up of three words. So you are going to use three reagents. So first is alcoholic. Why alcoholic? Because thalamide is not reactive in nature. So to make it reactive, we are going to treat it with alcoholic. Next is we are going to treat it with RX, any alkyl halide. And last, you have to treat it with aqueous NaOH. So again, in Gabriel Thalamide, you're gonna get primary amine. Done? That's it. These were the preparations of amines. Yeah, yes. Yes, yes, yes. You can. Any, sir? Any, sir? रिकॉर्ड हो रहा है रिकॉर्ड अभी तो प्रिपरेशन हुआ ना प्रिपरेशन कंप्लीट हो चुका है नहीं नहीं चैप्टर बहुत छोटा है इट्स क्वाइट इजी यस प्रिपरेशन ऑफ अमाइन केमिकल प्रॉपर्टीज बचे Okay. You done with this? दिखा रहे थोड़ा थोड़ा. हम्म. कर दो. 5 मिनट में वापस ऑन करेंगे. ओके. ना तेरा ना मेरा, सबका. Okay. You done? Um, the name of this is sodium thalate. Okay, I just forgot. Sodium thalate. Raina, you're copying this, right?
Ma'am, can you send me the PDF?
Can you what?
Can you send me the PDF?
Yeah, sure. Okay. I think actually this video has been uploaded in YouTube as well. Okay, this is going in live stream in YouTube. You know this, right?
I don't know.
Okay. So we have a channel that is Anis Defense Career Institute. So this session is going live in YouTube as well. So whatever you are talking or whatever I am explaining, this has been going in live stream.
Okay, ma'am. But still,
Okay.
can you send me?
हाँ हाँ, I
That
can, I can.
it will be easy for me to study from the
हाँ
PDF.
हाँ, sure. मेरे पास भी नहीं है. Okay, okay, fine. I'll send you. किसी को पता ही नहीं लाइव चल रहा है, बताना पड़ेगा. चलिए आगे बढ़े. Okay, let us move further. Hmm. Okay, that is chemical reaction में let us see the basic properties of amine. कि amine को हम why do we call it as base? The main reason is it is a Lewis base. According ऐसे नहीं, so there were in ionic equilibrium we saw three theories that related to base. First was Arrhenius theory. The next was Lowry-Bronsted theory, and the other was Lewis theory. Arrhenius theory, what he was telling, that any species which dissociates to give OH minus, that is base. But it is not important that whether if a compound is having OH, then only it is a base. If it is not having OH, then it is not a base. So it is absolutely wrong. The next theory was Bronsted-Lowry theory, which actually that scientist he talked about protons. Bases are proton acceptor or proton donor. They are proton acceptor. Yes, H plus acceptor. And acid is H plus donor. And the last theory was Lewis theory. In that he said bases are lone pair of electron donor. Ulta. Okay. So let us see the basic character of amine. This is very important. Basic characters of amine. So according to Lewis theory, bases are lone pair of electron acceptor. Sorry, it is donor. I'm extremely sorry, it is donor. Okay. So we also distinguish that what do you mean by lone pair? What do you mean by bond pair? So in nitrogen, there is a lone, but there is only one lone pair of electron. Okay. So in nitrogen, we can say there is one lone pair of electron. So this is lone pair. More easy it can donate the lone pair of electron, it will be a stronger base. So what would be the factors affecting the basic character of amine? ऐसे कौन से फैक्टर्स है जो बेसिसिटी को अफेक्ट करता है अमाइंस के? अमाइंस का हमने क्या देखे, जितना इजीली वो लोन पेयर ऑफ इलेक्ट्रॉन को डोनेट कर सकता है उतना वो अच्छा बेस होगा। तो ऐसे कौन से फैक्टर्स है जो उसको अफेक्ट करेगा, उसके बेसिक बेसिक प्रॉपर्टी को? कोई इफेक्ट नाम होगा, एक जमाने में इंडक्टिव इफेक्ट पढ़े थे। प्लसा इफेक्ट, डज इट अफेक्ट और प्लसा इफेक्ट वो बेस को स्ट्रॉन्ग बनाएगा या वीक बनाएगा? क्यों? स्ट्रॉन्ग बनाएगा ना। माइनस आई वीक बनाएगा। फॉर एग्जाम्पल सी, सो देर इज वन स्टेटमेंट, लेट मी राइट वन स्टेटमेंट। क्या स्टेटमेंट? प्लस आई इफेक्ट और प्लस आर इफेक्ट, plus I and plus R. Plus I is inductive and R is resonance effect. So they make stronger bases. How? For example, if I'm using CH3, NH2, this is methanamine, okay? And if I'm comparing it with CH3, NCH3H. So if I'm comparing it with the second structure, okay? Now, nitrogen is having lone pair. Both are having lone pair. But here, which will be a stronger base? Bases are nothing but they can donate the lone pair of electron more easily. It can donate when it is having a group attached to it, and it is क्या बोल रही मैं, a group which has plus I effect, and if it is attached to a nitrogen, so it can easily donate its lone pair of electron. Fine. So now nitrogen, what is attached? A methyl group. And here in the second structure, there is presence of two methyl groups. So this methyl group, it exhibits plus I effect. This also exhibit plus I effect, and this also plus I effect. अस्सलाम वालेकुम सर।
ऑनलाइन का कंसेप्ट केवल आप आए तो पर थोड़ी है पण लाइट नासिर खान का ये सप्लाई असं काम तो बोलो ना सर उधर से कि सब अपन करें सब लोग हॉस्पिटल ये लोग चिल्ला पुकार करते हैं इसका बैच है, लेकिन फिर वो दुबई से बच्चे बैठते हैं तो फिर वो कॉस्ट इफेक्टिव नहीं होता।
Okay.
मार्कर पे नहीं मार्कर
नहीं सर। Okay, so in the second structure we have two methyl group, and in the first structure we have one methyl group. So there in first structure there is only one plus I effect, but in the second structure there are two plus I effect. So obviously the second structure. So this methyl group, it will donate its electron. It will increase the electron ka intensity on nitrogen, so that nitrogen can easily donate its lone pair of electron. So that's why we can say methanamine is sorry, I'm extremely sorry. This the second structure. What is the name of the second structure? It is N-methyl methanamine. It is a stronger base as compared to methanamine. Done? Okay. What if, for example, okay, okay. Just a minute, just copy this. क्या हो गया? Okay. Um, fine. In aqueous phase, I'm giving you three options. CH3, NH2, CH3, NH, CH3, CH3, N, CH3, CH3. Arrange it in increasing order of basic strength. Which will be more basic in nature? Third one. Okay. Okay. I'll write as A, B, and C. First, you said B is more basic. Sorry, C is more basic. Then B. Then A. कोई बता सकता है ये स्टेटमेंट करेक्ट है कि गलत? Aqueous phase में we have three structure: primary, secondary, and tertiary amine. So which is more basic? Why C? Aqueous में. Aqueous हो या gaseous हो, कुछ भी. कौन पहला बेसिक होगा?
तो बी होना चाहिए, फिर सी और फिर ए।
C क्यों? मेरे हिसाब से C सबसे ज्यादा वीक बेस है. क्यों? मेरे हिसाब से my correct answer is B, A, and C. Now explain. Why C is a weak base, although it has plus I effect, three plus I effects. Then also it is a weak base. हाइड्रोजन का कोई लेना देना नहीं है. चलो मैं लोन पे लगा देती हूँ. What would be the reason that the tertiary amine is weak base as compared to primary and secondary? Any idea? Only plus I effect affect the basic strength, or is there any other effect which is also participating? Resonance है ही नहीं बेटा. Resonance कहाँ है? नहीं. There is one, it is steric hindrance. So when you look into the third structure C, although there is 3 plus I effect, but there is हमने क्या देखे थे, जितना easily वो lone pair of electron को donate कर पा रहा है, the more easier you can donate its lone pair of electron, the more strong base it will be. Okay, so although there are 3 plus I groups attached to it, it is donating its electron, but it is not able to donate its electron to any X groups. Although it is receiving a lot of electron to it, but it is not able to donate electron. Why? Because there are 3 bulky groups attached. So there is a lot of steric hindrance. Secondary structure, there is steric hindrance, but it can easily donate its electron. Okay, although uh, the path is blocked in this too, but it can easily donate. So we can say first is B, then A, then C. This question is always asked on this one. This is very important. Okay. But in gaseous state, the steric hindrance property is not applicable because gaseous state hai. Tab only we are gonna look into the 3 plus I effects. So in that, so this is for aqueous, and for gaseous state, tertiary will be more basic, then secondary, then primary. Because basic strength increases with the increase in the number of alkyl groups. But in aqueous phase, steric hindrance is important. That's it. What about aromatic aniline? And if I compare it with ammonia, okay, I have another structure that is ammonia, aniline, and I have ammonia. So which is a strong base over here? Aniline or ammonia? रीजन? मेरे को रीजन के साथ बताओ. वापस से बेस का डेफिनेशन बताओ. क्या है? लुइस ने क्या बताया? जो डोनेट करता है वो बेस है. बट एनिलीन में कुछ तो गड़बड़ लग रहा है. लोन पेयर ऑफ इलेक्ट्रॉन रेजोनेंस में बिजी है, तो क्या वो करेगा? This lone pair of electron which is present on nitrogen, it is busy with resonance. So this it it can't it can't donate its lone pair of electron. So we can say ammonia is stronger base and aniline is weaker in nature. तो फिर इसका pH क्या होगा? एक अंदाजा बताओ. वीक बेस का ज्यादा होता है. 7. बेस का 7 के बाद ही होता है, बट कुछ अंदाजा. 14 होगा. Will it be 14? Because 14 stands for strong base. Weak base will acquire like 7, 8, 9, 10. That's it. 14, 13, they are stronger base. Okay, fine. Okay. Why? Because the reason is resonance effect. Now tell me, in aniline and nitroaniline, which is stronger in nature? नाइट्रोएनिलीन, नाइट्रो कौन सा इफेक्ट दिखाता है? माइनस आई एंड माइनस आर इफेक्ट. Minus I, minus R effect. So we saw minus I and minus R effect, they both destabilizes the basic strength. It decreases the basic strength. So obviously the lone pair of electron, although this lone pair of electron is busy in resonance, but if we are comparing it with paranitroaniline, this will be stronger than paranitroaniline. Hanji. Okay. Minus R is electron withdrawing effect and plus R is electron donating effect. तो यहाँ पे इलेक्ट्रॉन डोनेटिंग इफेक्ट का एग्जांपल हम लेते हैं. वी कैन टेक चलो NH2 का ही लेते हैं. ओके, नहीं जाने दो, कंफ्यूज हो गया. आई एम टेकिंग Cl. Chlorine has lone pair of electron, so it is donating its electron. बट जब तुम नाइट्रो का देखते हो, फॉर एग्जाम्पल इफ आई एम यूजिंग नाइट्रो, तो यहाँ पे क्या होगा? ये माइनस है तो ये ऐसा जाएगा. Because nitro is showing minus I as well as minus R effect resonance. So it will withdraw the electron from the benzene ring. तो क्या मिलने वाला है? कुछ ऐसा मिलेगा. NO- डबल बॉन्ड और यहाँ पे द ऑर्थो का जो इलेक्ट्रॉन है वो चला गया, तो यहाँ पे पॉजिटिव जाएगा. ये फिर उसके बाद ये यहाँ आएगा, फिर यहाँ शिफ्ट होगा, तो ऐसे ही रेजोनेंस जाएगी. ओके, सो जस्ट कीप इन माइंड. सो इससे अच्छा तुम ग्रुप्स याद रख लो कि कौन से ग्रुप माइनस आर दिखाते हैं. चल क्यों नहीं रहा. नाइट्रो halide shows minus I and plus R effect. Because देखो ना, halide, it is donating its electron to the benzene ring, but it is showing minus I effect. Yes. और कोई एग्जांपल. साइनाइन SCN भी दिखाता है. प्लस I प्लस R कौन दिखाता है. ऑल द अल्काइल ग्रुप्स, ऑल द हैलोजेंस, ऑल द मेथॉक्सी ग्रुप, OX, ये सारे प्लस R दिखाते हैं. ओके. याद रखना, हमेशा याद रखो, whenever there is inductive as well as resonance effect in a particular compound, always remember the resonance effect predominates. It dominates everything. Okay. If it is minus I and plus R effect, for example, if I'm taking chlorobenzene, so the resultant effect is minus I and plus R. Minus I, why? Because chlorine is electronegative in nature. Why it is plus R? It is donating its electron to the benzene ring. So if like this, if you see like this, so always remember, you have to remember that minus plus R effect is predominating the minus I effect. If you want to compare the acidic nature, basic nature, अगर ऐसा कुछ दिखा minus I plus R, तो you have to consider only the resonance effect. No matter what is कोई भी माइनस कितना भी खतरनाक वाला माइनस आई इफेक्ट माइनस आई ग्रुप अटैच भी क्यों ना हो, बट आपको रेजोनेंस को ही कंसिडर करना है. डोमिनेट करता है वो. डन. ओके. हो गया क्या लेक्चर. 11:30 हो गया. आए थे ना वो. कहाँ पे. ओ. नहीं. ओके. तो वी हैव कंप्लीटेड बेसिक कैरेक्टर. इन नेक्स्ट लेक्चर विल बी क्या करने वाले. ओके. So in the next lecture, we'll be looking into the chemical reactions of amine. We have completed the IUPAC nomenclature. We have completed the classification. We have completed the preparation of amine, and there were 6 preparations. After that, we completed the chemical reaction, the basic characters of amine, why the factors affecting it in aqueous phase, in gaseous phase, and we saw okay, and then we saw the plus I, plus R, minus I, minus R effect. In next lecture, we'll be continuing it with the chemical reactions of amine, and then I think then in next lecture we'll finish this chapter. Okay, fine. Thank you.